We all know how to use chatbots and generative AI, at least to a certain extent. But chat applications are just only one type of application of using a large language model or another type of model to do some generative AI magic. Today, we will look deeper into the other types of generative AI applications, and specifically the ones that are relevant for our businesses. So for enterprises and for companies that have a lot of different tasks with a lot of repetitions, where they need to focus on efficiency in terms of wait time and processing time and quality, and reduce their process defects. So chatbots have been there for a while, even before there was really large-scale generative AI. Like I did the first chatbot already 10 years ago, and there's chatbots that date back until the 80s. But ChatGPT had a very specific moment in the end of 2022 where it made a new type of generative AI application that works pretty well, accessible to a larger amount of people. Everybody who eventually at some point in time in their life used WhatsApp or Facebook Messenger or any type of messaging app can use this interface. And this interface is just a wrapper to what we call these days a large language model. There were large language models before there were chatbots. GPT-3 has been existing before, but it never really got that large scale breakthrough because there was not a really easy way for people to access it. People rarely use APIs. The mainstream consumers doesn't really use APIs, even though these models were also quite powerful. But the chat interface made it so accessible to a larger crowd of people and to larger user bases. And that's why in many people's head, there is connection between the chatbot and a generative AI application, which is really not. It's just an interface on top of a generative AI application, and there are many more. And in many cases, a chat interface is not even what you would need or what is the optimal way to your solution. Chatbots are great if you have creative tasks that need interaction in processes that are always different. So if you want to use a chat interface over a large language model like ChatGPT to come up with catchy marketing slogan, or with a program that you would like to do at an event. These are typical one-time tasks that you have for a very specific purpose at a very specific event at a very specific point in time. And for that, these type of chat interfaces are great because you can work iteratively and you don't need to write the perfect God prompt first, but you can tweak it, refine it until you get somewhere where you are happy. Let me take this example here, which is a little bit of a different process. Jenny is a controlling assistant at a bigger company. Her job is literally nothing else than taking all of the invoices that she gets per month, look at the amount, check if the amount is the amount she wants, if it's correct, and in the end, map it to cost centers so that it can do their controlling. She can use a chatbot for that, and the conversation looks like this. In ChatGPT, you can upload invoices or any type of documents, and with OCR and a bunch of different other technologies, we can look into the text, extract them, and do some semantic reasoning on top of them. So she asks, here's my invoice. Is this amount 1,249 euros? After some analyzation, ChatGPT in this case says, yes, it is. She asked to which cost centers to map it to. We need cost centers because otherwise it will just make up cost centers. And here's a list. And after a list of what belongs in which cost center, this generative AI can pretty easily map this point to a cost center. But if we look a little bit deeper into the time that we have and the time that we save in different scenarios, we will find something very interesting. Assume we have a task. If we don't do any AI automation, any AI related tasks with that, and we do it 100% manually, and let's assume we have a task that is 1 hour, then all of the effort that we have for this task is manual labor, and it's going to be 1 hour. If we have to do the same task over and over again, we have literally 4 times 1 hour, because you have to do this task manually 4 times. You can't just copy and paste your manual work. This is just there. Now, let's talk about the time when you use for the same task. Let's say this task is specifically our example from the invoice and cost center mapping has come from, and we use this task in a chat. we use a one-time task with a generative AI-based chatbot, so ChatGPT, then we can save half of the time that we have for this guy, because we don't have to write everything ourselves. But what we still have to do is we have to write the prompt. Then we have to iterate over this prompt a little bit, looking into quality, looking into errors, doing adjustments, and wait until everything is generated. Let's assume we can save 50% of the time by doing that way instead of writing the whole text ourselves or doing the whole assessment ourselves. Next, let's look deeper into when we do that actually not one time, but we even do it 4 times. So if we have one task and we save half of the time and we have to do the same thing 4 times, then with a chat-based interface, you also save 50% of the time. But is that as good as it gets? Is this really the means to all ends, to sit there like you have your assistant that just helps you to do your tasks manually and just giving this 50%? No. Because when we really think about it, this repetitive task that we have, we need to write a prompt first, but we wouldn't really, if we do it smartly, we wouldn't have to write a prompt the second time if we're doing the same task. So why are we not having the same template if we are doing 100 different times the same thing, which is comparing invoices to the amount that we expect and mapping them to cost centers? So if we could have somewhat of a template for that, we could save a lot of this time in this direction. There is also a lot of time that we need for adjusting these prompts, because in every situation, we have to upload a different piece of data. We have to go a little bit different, but we are there and we have to work with the interface that we have got. Again, there, we are doing the same work manually twice, just that the vast part of the task is not done manually, but by an AI. But our oversight, all of the overhead that we have is not going to go away, and neither for quality control that we need to do manually anyhow. So we can optimize our work if we work with process templates and more efficient interfaces to really look into the process first and build something that helps. And in some reasons, the chat interface is not the best choice to do that. To get there, we need to start and we need to analyze our processes first before we start interacting with any type of generative AI chatbot or whatever. And we need to turn them in reusable and componentized templates to reach the full potential. We have to think of cases. So if Jenny has her invoices and she has 1,000 different invoices that she needs to control every month, then these are 1,000 different cases. And these cases have case-specific and case-independent input data. So case-independent data is that mapping that every time I have an invoice where someone is paying me for work by the hour, that belongs to the cost center freelancers. This is case independent. Doesn't matter what invoice it is. The storage of this information is always the same, so it's case independent. But the actual invoice, the number that this invoice should have, is different. So we call this case specific data. And once we start thinking about these categories of data, we can think about the process that we can do, and we can also think about the interfaces that we have to do to orchestrate this process. So what we really need to do in this case, we need to build an AI-powered application instead of a chat interface. And that's the core of where I draw the line between consumer-grade and one-time task interactions with a chatbot and actual enterprise generative AI that is tested, that has a certain level of quality that we can reproducibly expect and in the end use in a productive system and scale. So that means we have in the beginning a little bit of time that we need to invest in building the AI-based application, which is the same like we had before. But then when we are executing the same process over and over again and we just need to fill templates, we can for each of these cases reduce the overhead drastically. And this is where the real fun begins. When we think about these type of repetitions, about processes, about how to make our processes better and how our process automations and optimizations make an impact for our enterprise, we have to think on a bunch of different levels. We have to think, of course, about the process itself, but we also have to think about the environment based on which we can build our enterprise-grade generative AI applications. And the picture you see here is my reference case for enterprise generative AI applications. And that's the architecture that I would say. So any type of enterprise application with AI needs some sort of hardware to run all of these AI executions on. What we run on this hardware is, of course, the evaluation of a model that has been pre-trained at some point in time. We can use AI models as a service like ChatGPT or OpenAI's GPT-3, GPT-4o API, where we can get basically model completions over an API just like a commodity. We can also use on-premise pre-trained models such as Llama 2, 3, and whatever the new ones that are coming, or we can build an own model from scratch, which I encourage because unless you're Google, just the overhead to build a good large language model that can do a lot of things is going to be very expensive. Then on top, we can of course fine-tune these models. Fine-tuning is one way of getting information that was not in the trained model before into this model by using basically retraining on top of something that is already existing. That works, especially if you are looking to ingest data, how to phrase certain sentences or how to do something on a conceptual level. But then on top, we have a layer that is basically the orchestration. And an orchestration layer is basically mapping all the actions that are coming from the application layer. When we have somewhere of an application where there's a form where Jenny can upload her invoices, it's probably some sort of web interface. We need to get this data, this information that we have in a web interface and orchestrate it with a series of prompts, with a series of model completion, and with a series of retrieving context from databases. And this pattern is called retrieval augmented generation. And we are using a vector database to store our semantic data in a way that we can retrieve it easily when we need to. And this is exactly the point where we are seeing these 4 archetypes of enterprise generative AI applications that I want to show you today. Because you can use for 90% of the use cases of generative AI for text in enterprise, these 4 different archetypes. And we are going to go deeper into them now. Chat applications, we already talked about. Chat applications are great if you have one-time task and if you need an easy-to-use interface. Are they suited for actual correct data retrieval? LLMs without any retrieval augmented generation and have the tendency to do hallucinations. Here is a very good example on the right where I asked what is bigger, 9.11 or 9.9, and it tells me 9.11 is bigger than 9.9. That's not correct because it's not 9.11 and 0.11 is bigger than 0.9, but it is how decimals work. And if you ask there, it explains to you that it's a wrong answer. Never mind, these applications here are not meant to be your mathematical engines. There's the stochastic processes and statistical engines that help you go where you need to go, but it's not a mathematical guru. In the same way, if you ask for data that is not there or that it was not trained on, it will hallucinate. And if you are not using retrieval augmented generation, you are always prone to that in that way. And that is specifically also tied to the chat interface. Because when you have a chat interface and you have 100 different people that should do 100 times the same thing, and you all give them a chat interface, you have a lot of variation in how they write their prompts and how they structure their conversation with this generative AI in a chat application. So the likelihood that you have quality-wise something that is not optimal is much higher when you go with something where you have a lot of variation. And it's a tool, in my opinion, for one-time processes that you don't really have to think too much about, but it's not a tool where you have mass cases of the same thing, where you need to have quality guidelines, where you need to have quality assurance of the things that you are getting out. Talking about assurance of the quality of what is getting out. If we talk about knowledge, all companies have a lot of knowledge in their organizational membrane, if you want to call it like that. This knowledge is usually buried in a whole pile of Word documents, PDFs, Excel sheets, databases, and God knows what's in structured or unstructured ways. But getting out this information from somewhere in your organization is very tedious. That's why we are communicating a lot via emails to find out where the information is that we would like to have. We can use retrieval augmented generation with a large language model to make this, I would call it, corporate knowledge management process quite a little bit more accessible. That's what you see here is a part of our platform and engine where we have an application or an application type for knowledge search, and this product is being called Company Guru. So in Company Guru, you can just upload different types of documents, and you will see that you are looking into these documents whenever you are making a search query. You can also call it a little bit like your corporate Google, but what is really the interesting and good thing about it is that this is not keyword search. In keyword search, you have the problem if you're looking for the term stool, but you only have the term chair in your database, you will never find it because the semantics that a stool is a little chair without a backside, it's not encoded in there when you do keyword search. But with large language models and semantic search, we can put these type of nuances in a database and make it searchable. And that's the real key difference and the real key novelty that these new types of applications came with generative AI at some point in time. Here's the application that we built with a Dutch customer. We built a database of knowledge of how the Dutch pension system works and how the Dutch pension system is going to change in the next couple of years. So we have a question and we define a process where in the first step of this process, we are looking for an excerpt of text that is somewhere in our knowledge base that is relevant to that question. And the second step, we use that, we call it context information, to formulate the answer to that question. And with that, you can think about many different use cases, either if you're a researcher, if you're any type of knowledge worker, or even if you are in customer support, and you need to not have something hallucinated together, but you need to have a source that you can cite and that you can also easily check if the answer is actually true. And this is where knowledge search and these type of applications is number 2 of our 4 types of applications that probably covering 90% of all enterprise use cases. AI process automation. We can use large language models interactively, but often we have processes that have a very clearly defined sequence of things that you need to do. Whenever an invoice comes in, you need to look who sent it, who is the responsible team leader for that invoice, which project it belongs to, and then continue with asking the person if this invoice is correct, getting an answer back and forth. These are always the same steps and they're reproducible. And if we approach this application actually not like that, the large language model will just do everything at once without any big issues, but if we break it down into these small steps, we get a much, much higher quality than just going to ChatGPT and say, here's some data, generate a report for me now, and then wondering why it's not happening. We have to think in steps. We have to think in the different activities that you have to do in a process, how they are interlinked, and how data and intermediate results are cascading down. And this is what you do when you do AI process automation. And the last part that kind of combines or gives a different instance for that, of course, you can create all of these applications and all of these processes, and you can have different interfaces on top of them. And the last thing that I see really a lot is that we have applications where we, as an output in the end, need to create some sort of document, a text document or a presentation or something else. And when we work with these type of predefined processes, as I call it dynamic AI snippets, like you would do it with normal text blocks that you would just copy and paste, but that are not static. Instead, they change every time based on the input that you give. Then you have a very efficient flow when it comes to building documents. But therefore, you also have to think about, is it always the same type of document? Is it a report? What type of report is it? But if you are any type of expert assessor, or you have to write a lot of reports, reviews, assignments, offers, proposals, these type of things where you always have the same components, but you have different content of these components, then you can build small little processes that you can then put as dynamic snippets, fill them in with your case-specific data, and let them create something for you. And this is really the overview of the 4 different types of applications for generative AI in enterprises that you can use for probably 90 to 95% of all cases. Of course, you can embed all of these applications with an API to existing interfaces, to existing systems, to get knowledge, to get data, either case-specific or case-independent. Which application you need depends on a lot of different factors. Here's a nice little overview of all of them. And that's my end here, what I do with my company with Engine is we help other companies improve their efficiency with AI. And therefore, we implement these 4 types of applications on our platform. And we have standard components that we can just use whenever we would like, for whatever we would like, and build applications very fast. If you are interested in learning more about us, we have cases where we build with a dedicated team applications for you, or we help you build and upskill your own internal people, make them AI champions and give them the tools to build, especially these 4 types of applications and everything that comes around. With that, thank you very much for your attention. And if you have any questions, hit me up on LinkedIn, write me an email, or go to our website and get started.